to the Climate Hive Show. What do you solve? Where we talk to global game changers on climate. I'm Kevin Drolet, aka Kedro. I'm here with my Climate Hive co-founder and co-host, Mike Higgins, aka Higo. And today we are talking about the future of wind energy with Ocergy founder and CEO Dominique Roddier. If you're thinking big about renewable energy, you won't want to miss this show. And if you want to know why wind is such a big deal, we could not have found a better guest than Dominique to tell us why. So without further ado, I'm going to pass it over to my good man, Higo, to kick off the show. Thanks for being here, Dominique.
Hey, Dominique, so great to have you. Really looking forward to our conversation today. So we always begin with the aha moment. You know, every founder has that spark, that aha moment when the idea really kicked. You know, why don't you walk us through your story on the aha moment that led up to this venture?
Yes, so I started my career working for ExxonMobil in the oil and gas patch in Houston, and job was great, but the impact of working for an oil and gas company, even though it was 20 years ago, was a bit challenging. And so we left with a friend of mine that I had met in grad school, and we created a small company doing offshore oil and gas, but really marine systems. And then little by little, we started looking into waves, wave energy, current. And one day, a client of ours came out and said, "Oh, we need to put these little wind turbines." And we had worked on it. It was called architecture wind. It was a five-bladed for real estate type of stuff. And I said, "Let's put this out in the water." And that's how it got started. Like this is what we need to do. This is really what the future is about. Not a little 2 or 3 kilowatt, but let's see how big that can get. So we partner with different people, and we had a long story with the first company that was created with one of our clients from the first company called Principal Power, and we developed I think about 150 megawatt of projects with them. And then we started Ocergy, and we'll talk more about this a bit later.
That's awesome. I love that you started in oil and gas. What a perspective. You know, what I'm because oil and gas is obviously extremely important and did a good job for a long time, but now it's time for emerging technologies for sure.
That's right.
So let's talk about the combination of wind and offshore, right? Because obviously the wind blows onshore too. But you guys are really, as you can see those awesome pictures behind you, you guys are really, pioneering, wind offshore. Why is floating offshore wind such a big opportunity right now?
So you go where the resources are. And if you want trying to develop large scale projects, so we're talking about gigawatt scale of electricity. This is electricity that goes straight into the grid that just powers everything. You go where the resources are with the technologies that you can. So onshore wind and solar, solar farms, they work great. But you're kind of limited by the land use. If you're using
Mm.
solar panels, you have to compete with agriculture. And onshore wind is not very popular. They're pretty big wind turbines, they make noise and so on. And when I say pretty big, we're going to talk about very big. Pretty big is like a 2 or 3 megawatt turbine, blades on 40, 50 meters. You start having a hard time moving those through highways and trains and stuff. So when you go offshore, you have pretty much untapped resources, huge spaces, no limitation to where you go. Wind turbines can get a lot bigger. So as I started mentioning, we were working with 2, 3 megawatt onshore. Today we're working with 20 megawatt turbines offshore.
Mm.
Those turbines, the blades, I'm going to talk, in meters, but they're about 150 meters long, so 450 feet. That is more than the diagonal of a football field. People used to say, "Oh, the diameter of a wind turbine is a football field." Now we're talking about a blade that you put diagonally, and it gets out on both ends. Turbine is about 2,000 tons, maybe even more for the big one. So this is offshore wind. We go offshore, we put those. Now, most of the time you try to go near shore where the water is shallow and the tower, so you get on top the
Yeah.
nacelle and the blades, and the tower goes straight into the seabed. So this is all of the projects that you see in Europe. Those are the projects that have been developed on the East Coast. And we can talk a little bit about what's going on with those projects as well today, but eventually they will get built. We can't stop that. This is really the future. But 80% of the waters are in deeper waters than the 40, 50, 60 meters that we can develop those projects. So if you cannot put the turbine all the way into the seabed, you have to make them float. Now, all of a sudden, you're further from shore. You're not in the shipping lanes. You're not in the what we call NIMBY, not in my backyard. People don't see them, and you can go very, very big. And that's what we need for changing the way we generate our electricity worldwide.
So how did you, because I know part of your history is like you were building big things in the sea and you come from a deep understanding of physics and we talked before about, and I'd love to talk more about the relationship between what you figured out, how you learned it from sailing almost, right? Like it's like
Mhm.
you're, well, the way you explained it. But can you talk a little bit about like what you knew before, how that translated into doing something that there's not a lot of companies building these massive offshore wind uh,
Mhm.
deals, right? Like it's just,
That's
it's
right.
not the case. It takes a special understanding of physics and other things to make it happen, right?
But there's not a lot of naval architects either. I mean, in the US, there was maybe
Yeah.
5 or 6 programs that where you could study this. There's hundreds of aerospace engineering programs. It's the same, it's fluids,
Mm,
but people are more attracted to airplanes and the air than the sea. But as a naval architect, what you learn is 2 things. How does something move in waves? And then what are the forces that the wave create on the structure, so impact on the structure, and how do you design a structure to withstand those forces? So one is hydrodynamics, the other one is structural engineering. When you combine the two, you have pretty much an architect. You add it to the systems and so on. That's what you do. We can design, and we've worked on a huge variety of problems. There's the same equations, the same tool. We've worked on very small wave energy device making, a few watts. I mentioned before we worked on an airplane that had landed, and the minute it lands on the water and the floaters expand, it's no longer an airplane, it's a catamaran. So,
mm.
things that we do. Floating wind is a little bit different, but it's the same physics. The wind blows on the turbine. The turbine spins. It forces the turbine, the whole floater to heel. There's stability in the floater, creates the restoring force, and brings it back up. And it's the same, whatever it is that you put in the water.
I mean, you said one of those blades weighs, did I get it right? 2,000 pounds, or is it 2,000? How much?
I'm
How
sorry,
much?
2,000 tons.
Yeah,
It's
so
2,000 tons.
each one weighs 2,000 tons, right? So there's three of them.
The turbines,
Yeah.
and then the floaters, another, 2,000, 2 or 3,000 behind that.
And I'm looking at the picture behind you, and obviously it's up. It would have to be way up there because of how long the blades are.
That's correct.
It's fascinating to me that you can put that much weight that high on a structure and not
Yeah,
have it tip over. I mean,
yeah.
it's remarkable,
And
you
when my
know?
wife was on my sailboat, she's like, "We're gonna tip over." And then I say, "No, because
Yeah.
when the boat heels, the wind stops blowing on the sails, but your keel is pulling you back up." So you just have to, Kevin, as you mentioned, you have to trust the physics, you have to trust the math. It's the same equations that apply. It's the same science works. So
Yeah. It's fascinating. Hmm.
So, Dominique, can you give us a little picture on wind energy and big picture? Because that was something also in our pre-show we thought was really fascinating is you have this perspective because you're working on projects that won't come online for a little bit of time. That they're very expensive, they're very big. But can you talk to us about size and scale? of what you're doing, how much power it's going to develop, and why you're why you're optimistic about it.
Yeah.
Because wind gets a bad rap sometimes, I think.
So today we are working on a 3 megawatt pilot. So it's Vestas 3 megawatt. This is really to prove our new technology. So we're a company that's 5 years old. So even though we've been in the industry for almost 20 now, when we created Ocergy, we start from scratch. We wanted to do that because we needed to go to the next step. What we've done in floating for the entire industry is we developed first pilots, 2 3 megawatt pilots. There's about 8 or 9 of those. Most are in Europe, a few are or were in Japan. So what we showed there is that we can make a turbine spin on a floater. And the way we look at that is we look at the power curve of the wind turbine, and we compare the power curve that we were getting. When the wind blows, you create power, and depending on the strength of the wind, you have more or less power. And we compare that to what was the theoretical curve and what we were getting on offshore, bottom fixed, and onshore. And so we showed that they were right on top of each other. So that was the first step. So that was about 2009 to 2004, 11, and then 15, 13 in Japan, and some in 19. So today that's what we're doing with the 3 megawatt because it's a new technology. But then the industry went to pre-commercial, what we call pre-commercial projects. And what we're trying to find there is, at least for Principal Power, my previous company, is how do we bank finance those projects? And so we looked at, and those projects were in the 30 to 50 megawatt. So we were using 10 megawatt turbine at the time. So you can see 3, 4 turbines. And we had help. We had applied for European grants. Mostly those projects are in Europe, different schemes in Scotland, in Europe, in France. And so when you remove the help from the government, then the developers would actually bank finance part of the investment. And the reason for that is because they're creating electricity for the next 25 years, and they're selling the electricity at a specific price. So that's what really the industry is. There's 5 or 6 projects between 25 and 80 megawatt each. Those are built, and most of them are in Europe. There's only one in Japan. What do we do next? And next is how do we develop commercial projects? So first we're going to develop small scale commercial projects, and then we're going to go to large scale commercial projects. The small scale commercial projects, you need to develop a project. So we're not the developer, we're a technology provider. Our clients are the developers, and you're talking about big utilities or oil and gas companies. What do they need? They need 3 things. One, they need site control. So this is very similar, since we're in the US with BOEM and MMS and Bessie was doing for oil and gas. So you need a lease, and you need to have control of that site. So that's what's done in the US through auctions. Then you need what we call in the UK consent. So consent is permits or a path to permits. And there you have to look at all of your environmental impact assessments, working with all the NGOs. In California, we have, pretty much everywhere in the US, we have tribes, and so on. And then we have to work either with the federal government or the state government, depending if we're more or less than 12 miles offshore, and so on. So once you have all of your permits, you've reduced this. So you have control to the site, and then you have your permits. Then you need what we call globally a power purchase agreement, so a PPA. So you negotiate that with the different type of government. In the US, it's mostly through the UC, so the California Utility Committees for us has a big part. In Europe, it's mostly part of the government. People that follow a little bit of showing, they heard about the CFD scheme in Germany. In English, CFD scheme is a contract for difference. You have a merchant rate of electricity, and then for certain project, the government will pay more. And those CFDs are different based on the different technologies, and that's how they actually try to level the playing field and get a large portfolio of different type of energy into the system. So that's where we are right now. It's actually quite an interesting year, because both France and the UK will be granting what they have already granted two projects in France on the steam for 250 megawatt. I'm talking about floating, and then one the year before. But now there's going to be 2 sites of about 500 megawatts that will be announced, and there will be bid and then announced sometimes towards the end of the year. And then in the UK, they're also announcing 4 big projects between 50 to 200 megawatt. So there's quite a lot of excitement on those projects. Last year, there was one. It was a project called WindVolt that will be the largest project installed around 2030. But then there's more coming. So people are really attention and working hard to change the landscape of our generation. Once you start looking at 2035 to 2040, now we start talking about a gigawatt scale offshore wind. So with a 20 megawatt, you're talking about 50 units of 20 megawatt. So those we're talking about. A gigawatt scale is roughly the scale of a nuclear power plant, to give you, back. So that's really what we're against, or what we're trying to replace or complement. What we're trying to replace is more coal, and make maybe offshore wind or renewable the main source of electricity, and then have gas be the intermittent, just because we can have, when you have multiple projects and you combine, in terms of renewable, you have, projects in the north, projects in the south in wind, you have solar farms, and then you combine that with a smart grid and battery storage, and now you're the primary source of electricity. And that's really for 2030, 2050 timeframe.
So with those three, because that I can see why. So you've got utility companies and oil and gas companies that are actually taking the technology from you and doing the implementation, and they have to get through the regulatory environment, which I'm sure is pretty pretty mind-bending. But I would also imagine that those companies are used to that, right? They're very used to that, right? Because wouldn't it be the same case no matter what kind of energy development you're looking to make, whether it's solar or coal? I mean, aren't you going through kind of the same process? So it sounds to me like those guys would know how to navigate those, those stringent requirements.
They do. That's why we're not, we're technology providers, we're not developers. This is, there's some specificity, obviously, when you write, a crop, the crop is a plan that you write for an operation plan, construction operation plan. Obviously, you're operating a wind turbine, you're not operating a gas plant or a nuclear power plant, and so on.
Right.
There is a system that you have to do. What's different is the permitting phase and the site control. So people need to want, the government, they need to want to change that. Say, okay, go ahead and develop a wind project. Go ahead and develop a solar farm. So.
Okay.
And then they need, to give you a price for that and say, yes, I will buy your electricity. A few years ago, there was a big utility on the East Coast, and the CEO was claiming, it takes me 10 years to build a nuclear plant, and it takes about, so there was one of the first offshore projects, and was, about 15 years into the, process and lawsuits and things like that. So he was like, I'm just going to do nuclear. Okay, we need to do better as an industry. So the wind industry, we need to do better to fast track the way we do projects. So we'll get there because we don't really have a choice. If we want to get to the targets that we need to get, basically we say if we want to raise the temperature of the Earth by 1.5 degrees by 2050, then we need to have a carbon neutral electricity generation. We can't be burning coal 20 years from now. It's just not possible.
I agree.
So that's why we'll get there.
Well, and it seems to me like you have solved the biggest problem related to wind offshore, which is not in my backyard, right? I have to imagine that is what gets people the most riled up, because we've all seen wind farms offshore. They're close to shore and they're enormous, right?
Yes.
And they're an eyesore. So you've solved that problem. I think that might be the breakthrough. Plus the enormity of size. I mean, you've built these huge windmills, windmill, so I think that you guys have really sort of crack that code in terms of, how to remove a big barrier to this.
Yeah, so that's our industry, not just us. I think that today we still have a few challenges. Um, it's expensive. Not too many people want to see it. There was a lot of hype a few years ago, and then obviously everybody started investing. But when there's a lot of hype, you have to, there's a fog that goes around. So this hype kind of, slow down, and this year, and with the Trump administration on one side and the price of steel
Mhm.
coming up, there's a lot of questions about offshore wind.
Mm.
What the main thing is the economics, and so what we focus on is really how do we reduce the cost such that the cost. So I said you're going to bottom fixed is your tower goes in the water. So obviously you can imagine that if you're in 5 meters of water depth, and if you're in 60 meters of 180 feet, 200 feet, the foundation is going to be more expensive. But
Mhm.
the turbines are going to be there, the resources are going to be there. So eventually, your LCOE, the levelized cost of electricity, should be the same. For floating, we need to be at the same price in 60 meters as the bottom fixed, because then our price stays the same whether we're in 100 meters, 200 meters, 700 meters like California.
Right.
Should be the same price. The mooring is very light. We use big polyester chains and polyester lines, so over the water, the water height. So that's really how do we do this? And you asked me about the haha moment. We had another one, which was at Ocergy, and this haha moment was really about supply chain, and it was about how do we make those projects. And so in 2019, just before we left, and then COVID was there, so we spent a lot of time reading stuff, and I focused a little bit on the Toyota production system, which is very interesting. How did Toyota manage to beat all of the US companies back in the 80s, 90s? And they did it using really industrialization perfectly. Is two pillars. One is called just in time, and is really make what you need. Don't make more, don't make less. Reduce your inventories, be efficient, and reduce the waste. So don't build bigger than you need. Don't just do what you want. And then the other one is called. It's easy to remember. It's not judoka like the sport. Is judoka, and this is really automation and quality. And it's the quality. It's quality management. It's doing the right thing so you don't go back and do it again. So you start thinking about, okay, we've been talking about industrialization for the past 10 years. How
Mm.
is it that we do it? And a lot of times, a lot of people were looking at, okay, this is our floater. How do we industrialize it? We went back the other way around. It's like, we need to industrialize. Let's design a floater that can be industrialized, and let's cheat. Let's figure out what people are doing. You take a wind turbine, has three blades and a cylinder hub, and a tower that comes in three pieces. They're connected by flanges. Pieces are built in different factories, and they're brought to a site, and then they're assembled. The blade doesn't see the tower until they're at the site. So we said, let's build the whole the same way. So let's work with the global supply chain. Where is
Mhm.
it that we can fabricate that's cheap, with quality? So we're talking about Asia, we're talking about Southern Europe, we're talking about Mexico, maybe Gulf of Mexico, and so on. And then when you're close to a site, let's just use a K, but it doesn't need to be a very, very big K with welding and painting and all those. It just needs to be a K with frames. And then we'll just assemble, put the turbine on, and go offshore. And remember, I mentioned we need to do 50 units for 1 gigawatt projects if we have a 20 megawatt turbine. That's 1 unit per week. So we need to create a floater that's in the 3,000 ton that will carry a turbine that's in the 2,000 ton. We need to assemble it in 1 week, put the turbine on, get out, come back, get out, come back, get out. This is exactly what Toyota is doing and what all the car companies are doing, all the plane companies when they're building things, in chain. So that was really our big aha moment at Ocergy, where we're like, okay, this is the way we should do that. Yeah. Boats, we talked about naval-architecture. have never been done this way. Oil and gas platforms have never been done this way. It's always a one-off. So how do we do, 50? And so this is really how we're solving and why we're so confident that we will be doing floating wind in the future, because people need it and we know how to do it. So now it's
So,
we just have to prove.
what was the impact on price? Because you sort of started this discussion
Mm.
of your aha moment and figuring it out. What did you discover in terms of cost reduction, or the time by leveraging these methods that uh,
Yeah.
Toyota
So
used?
if you want to, so this is something I learned back at Exxon. We looked at, this thing. If you want to reduce the price of something that's fairly big, a very big project, you're not going to reduce by 20% by cutting something out, because you always need something. So if you need to reduce by 20%, you need to cut 20% through every single step through the process. So your
Mm.
engineering needs to be more efficient. Your structure needs to be 20% lighter. So we have, some innovations and things like that. Your fabrication methods have to be 20% cheaper. So this is where we start doing this. Your installation is so 20% less time. If your structure is lighter, your mooring system is simpler. You have, we can have 3 mooring lines instead of 6. So it takes you half the time. So half the time is about 20% cheaper, and so on. So, if we can get to the 20%, then we're there. It's just, I mean, yeah, people say, okay, price has increased by 40%, but yeah, maybe that's the price of steel. And then you can negotiate and you can go to different places to get that. So we're
Mm.
talking about, a 20%, but it's not just in one area. It's really all across the board that we focus on. So really the word is holistic. It's
Mm.
holistically that we have to reduce the cost.
And with the manufacturing process, is it fully assembled before it's towed out to wherever it's going, or do you tow out the platform and then attach the wind element to it? Because I've seen on your site how you have the platform is being towed, right?
Yeah.
So I'm just curious if it's all final
So
assembly on land.
in bottom wind, you have your foundation and then the transition piece in bottom fixed. And then you have those very, very big vessels that come out with the turbine, and then they put the tower on the turbine and they do it. And they do it in a couple of days. This very big vessel, the whole industry is pretty efficient. But those are very, very expensive vessels. The
Mm.
good thing about floating is you can put your turbine at quayside. So usually you build your hull, you put it in the water. So you go to a big shipyard, and this is what we did with Principal Power, and pretty much everyone does that. You put it at quayside, then you have a land-based train that will pick up your tower in 1, 2, 3, and then put the nacelle and the blades. For them, it's an installation. It's a typical installation. They have the crane, except that the water is like 2 meters away from where the crane is, but you reach out. Where we're a little bit different is we have one more step, but we make it faster because we go to, as I mentioned, the people that know what to do. So we fabricate the columns and the trusses and the tendons in places that know how to fabricate that. And
Mm.
then we ship that to the nearest K, so the K that's the closest to what the project is going to be. And then we bolt the structure together, but it's the same
Okay.
bolt, it's the same methodologies as the turbines, as the tower. So, it's the same company, different companies, doesn't matter. It's, it's the same steels. And so it gets bolted, we put it in the water, and then we're back to the same step. We put the turbine on and we do offshore. The beauty is if you're going to be fabricating your entire structure and you're going to say you're going to go to China because it's a lot cheaper, you're going to come back with one big vessel with maybe one or two structure in the back of the vessel. So if you have 50 units, you don't have 50 boats going back and forth. If you collapse the structure, it's kind of like the IKEA model, right? You buy, a big piece of furniture, it takes you a truck. You put it into a box and you put it in the back of your pickup truck. So it's the same concept. We can put 10 units in the back of a big vessel because we're packing the columns right next to each other, and then the truss is on top and the tendons on the side, and off you go. So
And then you have like a really big Allen wrench that's also included in that.
have you seen the size of, so I have pictures, the manual ones, they're about 4 feet long.
Are they?
The IKEA model is so good, and they have those pictures, right, where the whole thing is miraculously coming together,
Yeah,
and
exactly.
you're supposed to interpret that. But that is, I mean, you guys have really got interchangeable parts down to an art, just
Yeah.
and of these huge machines, basically, but 10 at a time is the way to go, you know.
Yeah.
Yeah. Then it's a good way because if it takes you a week to assemble, then you have a 10-week shipment. So 2 months, 2 months and a half. If you're so the other thing is what happens if something happens. You always have to think about risk and risk management. So
Hmm.
now you have 10 units that are coming, one after the other, and then you have an issue with the turbine generator or something, or really bad weather, or major strike or something. You have all your units and they're there, and you don't know what to do with them. And so, but they're still coming out because they're still fabricating, and you want to get them out of the yard, and so you have to stop that contract. But then that has a lot of implication. So in our system, you can store, and you can store on the quay, not in the water, and it doesn't take that much space. And so by doing this, if there's an issue, you just pause and store a different location until you fix your issue, and then you continue and come back up. So it's a lot of things, a lot of reasons to do it this way.
Actually, you've told us this great sort of story comparison to this idea of like wind versus oil, just to look at like and finding locations for oil and dredging and moving these ships. And I wonder if you can talk a little bit about that, because one of the things that was interesting when we first met is like in many places, wind just doesn't have a good enough the story being told about wind is not good enough, and it's this super powerful thing in terms of what you're able to do. So I wondered if you could just walk through like a sort of a capex on an oil development project versus the capex on what you guys are doing, and how that looks when you do them side by side, just for
Yeah.
people that don't know.
Also, we talked about oil, but we also talked about gas and gas plant, which maybe it's easier to think about the gas plant first, and then we'll talk about oil. But the capex of a gas power plant is about $1 billion. And the price of gas right now is about $40 per megawatt hour. So if you do the math, that comes very, very quickly in the billions, but for the next 25 years or 30 years or 45 years, so that really grows. When you're looking at the capex of an offshore wind farm, it's more complicated. You're going offshore, you've got things, maybe it's like two or
Hmm.
three. But once you install, except for your O&M costs, which are fairly, yeah, okay, so you have to fix the turbines, fix what breaks, but it's nothing major. But your wind is free. So you're never
Yeah.
buying wind on the stock market and wondering how much that's going to be. And after 5 years, you're making money. 10 years, 20 years, it makes a lot of sense. Oil is a little bit of a different business because you're not selling electricity with oil. You can, from the gas or things, but you have, different use for hydrocarbons as well. But then the concept becomes, there's some analogies. First you have to find oil, so you have to drill. So your geophysicists are looking, and then they say, okay, that looks pretty good. So you spend anywhere between 20 to 100 million just to drill the well. It's a big range because if you're drilling a well in the Arctic with in kilometers deep, it's going to be a lot more than if you're drilling a well on the coast of the Gulf of Mexico. But it's very expensive, and then you don't know what you're going to get or not. But eventually, what you're going to find, and the reason why the oil and gas went offshore in the late 70s, 80s, and 90s with such a bloom, is because we found those elephant field. That's what they're called. And you're talking about more than 100,000 barrels per day of production. West Africa, Gulf of Mexico, and Australia, and so on. They're all offshore. And for us, it was the same, it was really the same thing. There is more wind offshore as well. If you look at the land, you've got mountains, you've got heat, you've got cold, it dries, so your wind is, a lot of local things. If you go, 200 miles west of California. The closest land after that is Japan. So you know the storms are coming and nothing stops them. So when you see the storm, the wind just blows. You know, the UK is the same thing, Scotland. Those are extremely good sites. You know, same, you know, France with the West Coast, and so on. So it's just you don't have the storm effect and you can predict very, very well. You know, a storm is going to blow for 24 hours for the next 6 days. There is no, oh, you know, it's going to be hot. So, you know, there's the thermal effect that change. So much better resources as well.
And it seems to me that over time, nothing is going to be able to compete with offshore wind from an energy production perspective because you're not limited by land. You know,
That's it.
you can build these gigantically scalable energy infrastructures because you're on the ocean. You know, you're not going to run out of room. There's not communities and houses all around you. There's not buildings. There's not mountains. You know, it's just the ocean. And you've solved the floating problem. So you don't even have to be a place where you can reach the ground with, you know, with the stability. I mean, it seems to me like you have really, this will become the only game in town. Is that accurate?
Yes, especially if you start combining, you know, sites, because you do have times where there's no wind. So if you can combining the offshore wind, you know, both fixed and floating with, you know, projects in different areas, north, south, things like this. And then you start combining this also with solar farms
Hmm.
on land. Hopefully, I'm not a big fan of solar farms because you compete with agriculture. I'm a huge fan of distributed solar. I think that in cities, every third house should have solar panels on the roof. And then people should be allowed to create small utility companies and resell to the grid and so on. We'll get there. So when you start combining all of those things with a smart grid and storage, whether it's batteries or hydrogen or something like this, then this is really how we're going to be generating our electricity in the future. And we can keep the oil and gas to things that are, you know, much more difficult and that you cannot do with wind. I mean, there's a lot of uses for hydrocarbons, and we need to save it for that, not for generation of electricity.
So how does storage, what's your take on storage, or how does that work with what you're developing here? Or do you need particular types of storage or
Plants, I mean, progresses are, you know, it's a lot of progress. There's very, you know, different type of storage. It's more classic and less, you know, more towards, you know, still towards batteries, but new batteries and things like that. I mean, when you look at, you know, a Tesla is 100 kilowatt hours or something like this. Something huge is like 3 days of your house production. So why can't we just plug in our Tesla into our house for 3 days? You
yeah.
should be able to, and eventually we'll get to. So that's one part of storage. I think that for big infrastructure, we're more talking about other sources. A lot of people are talking about green hydrogen. Every 20 years it comes and it goes, and so there was books in at the turn of the millennium, around 2000, called The Hydrogen Economy. It's a very, very good read. People kind of invested a lot of time and effort into this, and then it kind of went away. And now it's popping back up, but now it's also people are saying, oh, you know, it's difficult and so on. It, it will work. You know, it will work whether it's in the form of ammonia or something. We need to solve those challenges. Um, so for the bigger scale.
That
Dominique,
is.
what would you say what do you think are the biggest headwinds for you and what the sort of dream that you're trying to bring into being here, these major projects? What's most challenging?
Today is the politics or the vision. I mean, there was a lot of
Mhm.
hype And now there's a lot of fog around what happened. So it's that probably the hype hangover. 2025 was like this. So a lot of my friends were had to change industries, whether it was in the developers working in California, whether it was companies in Europe that lost their investors, US investors, and so on. So there's a lot of skepticism coming from the investors. I think that's our challenge today. We will pull through, for sure. We have to succeed because climate change is real. People know that, and they want to see a change. So the younger generation, they're all into what we are doing, sustainability, etc. So any type of hype, will go away. And then what will be left behind are the strong projects, the strong teams. And then those are the ones that will, take it and do the project. There's there's a quote, I wrote it down. There's a person, his name is Herben Rogen. He's a Dutch, but he worked in the UK for the Crown Estate. And I just saw an article, and just yesterday I read it. And he just said, so I'm going to quote him, the great offshore wind reset is in full swing. And those able to navigate through the fog and confusion, dot, 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 the reward remains as attractive as ever. So this is a person that created a lot of the first wind projects in the 2000s and so on. That's really saying, yes, there is a hype. Yes, there is a crash. Yes, there is fog right now. But when the fog clears up, floating offshore wind, floating because we're a small part today, but a significant part that will grow. We will be there, and I think that's really the message. And I think this quote is very important because this is a person that has been creating a lot of the offshore industry over the past 25 years. Someone that's been around and very respected, and that's why he sees that the fog will dissipate and the right projects and the right company will be there. And we're seeing this through the projects, but we're also seeing this through some of our investors that are very supportive of what we do. They continue to reinvest. And there's a few others, a few other companies that are, actively supported by their, financiers. So it's not, this, let's go invest and we'll find, 30 offers or so on. But we'll find the right people that want to see this, and they'll do well.
You guys are attacking a big challenge, which I think is very interesting. I mean, you guys are going after, utility grade, utility scale, energy production. So you guys aren't thinking small, man. That's for sure.
Definitely not.
My first job was with ExxonMobil. I worked on a platform that was 100 meters in diameter for 500 meters deep.
Yeah, you guys are thinking that big, man, because this is big what we're talking about. I think
Yeah.
that's one of the things that makes it so fascinating is just the scale, right? The energy
Yeah.
production, the scale. You're dealing with governments, you're dealing with oil companies, you're dealing with utilities. I mean, the biggest players, you know.
That's right. Yeah.
Yeah.
It's fun. It's fun.
Well, I
You, you
think
know the
we're probably at time, but I don't know if there's if we got asked you all the questions, we'll definitely have to come back and talk to you because we're going to check in on your progress. But is there anything that we didn't ask you that you really wanted us to ask you just to check in?
No, I think you really covered it. I mean, we talked about the projects, we talked about climate change, we talked about, the energy transition. Uh, it is a challenge. And the reset that Herb is talking about is definitely a challenge, but I really believe that it's a moment. It's a moment to not our
Yeah.
Ocergy, but our the offshore wind industry. It's a moment to come back strong and through the 4 or 5 projects that will come in to show that those projects can make money, can be executed very very rapidly and be at the forefront of the next 15 or 20, 30 years.
So we've been having a fascinating discussion with Dominique Roddier of Ocergy. Ocergy is pushing the boundaries, literally, of clean energy production, leveraging offshore wind. It was a big conversation, a lot going on. We look forward to following up with you again in the future and seeing how things are going. But it was an absolute pleasure to have you. Thank you so much. Incredibly interesting conversation. We really appreciate it.
Well, thank you so much for the opportunity.
Yeah, thank you, Dominique.